Welcome to Wickerson Studios. This is actually going to be my longest video I've ever recorded, and it is the beginning of a project that I initiated a couple of weeks ago. I began by finding this book. I found it online, and I simply started a Facebook page and asked, well, actually, I think I was on my own page, and I said, does anybody seen this book? Have this book? And if so, would anybody be interested in translating it from Chinese into English? Now, I'm not interested in the Chinese text. I'm actually interested in the scripts within this book. And they are Python, GhPython node scripts for Grasshopper to be used in Rhino. They're written in Rhino script syntax. And I'm interested in writing scripts that are dealing with Rhino Common. And there's several reasons for that. But mainly the reasons that I've come to is that I've done a few courses online, including Jeremy Graham's LinkedIn class, which dealt with Rhino's.geometry or Rhino Common geometries as opposed to GUIDs that are scripted in Rhino script syntax. I'm currently taking a course in Future Learn, which is out of the University of Michigan, which is a pretty fantastic class. And I also found this site through the Facebook group I started, where you can go in and find GH scripts that are written starting in Rhino script syntax, but as they develop farther, you'll find more and more of these scripts, which are available, the GH files. This is atlv.org, educational site, and you can see that these scripts become more and more elaborate, and they start using Rhino geometry. I'm going to go off the advice I received from Jeremy Graham that don't import Rhino script syntax and Rhino geometry. Try and do it all in one or the other, and the one to choose would be Rhino geometry. So I'm not pressed for time here. We're 2 minutes in. It's going to be a longer video. Those are some resources that got me started. I'll just delete those. I started this page in a matter of under 2 weeks. We have 268 very interesting professional international developers that have jumped on board. And I have been posting as fast as I can scripts as I learn, and thank yous and welcomings to most people. My studio is set up pretty much like this, out in Kansas City, Kansas. There's a little history of myself. I've tried to build a video series in the last 3 months, which is actually on my YouTube channel, which I would invite any of you to jump in and join. The playlists on that channel have come about in the last 3-4 months, and I began with a Tinkercad series of Rhino ABCs 1, 2, 3s, 1001 Rhino scripts, which have slowly moved off in development, a little bit for our jewelers, and into the GhPython 2020 project. Now I started that, and I've already made 23 videos in this last 2 weeks, as I anticipated receiving this book in the mail. And this book came in the mail, and I received it yesterday. And I opened it up, and I realized I don't want to copy ideas, steal intellectual property, but I want to go into it and use some of the ideas within it, written in Rhino script, and convert it over to Rhino.geometry, or Rhino Common. I'm also going to import one other thing, Rhino Maths, and I'm going to try and jazz and funk up all of those wonderful scripts on the import side and the outporting it into Grasshopper nodes, and start to build some very interesting sculptures, projects, algorithms, and formulas for anything that I can imagine. So there's the book that's inspired me. I'm going to stay with this series. And of course, the first chapter is a very basic introduction into the GhPython node and how to use it. So what we're going to do now, we're 4 minutes in, is I'm going to take a 20-minute say and try and run through how you start doing this. And I will close this. I will take this over to the other screen for now, and we'll slowly bring it in. But the first thing I want you to do is open your Rhino, Rhino 5, Rhino 6, whatever you have, working process 7 for Windows. The only thing I want you to ever do in Rhino is possibly set up your layers, because we might be baking some forms in on layers. And you don't even have to add a point. Put it to perspective. If you know Windows works well, simply slide it over to the side and shebang. 5 minutes in, we're going to type in Grasshopper for the absolute beginner. And what happens is a Grasshopper window pops up. And I'm just going to get it ready because I already have mine open. You're going to have a window pop up like this. Now, we're not going to make things in Rhino directly. We're not even going to make things directly in Grasshopper. We're actually going to go in and start following these instructions. Interface. Open Grasshopper Rhino command line. Type in Grasshopper. Drag a GhPython script node from Maths, Scripts, Python, and pop it into your canvas. You've succeeded. Let's go on to step 2. Try not to make this as boring as it can seem, but if you don't take the baby steps of the foundation into Python and use this as a tool to maybe refresh it, we're going to go all the way through variables and lists and data structures, skipping dictionaries, and jumping into functions in this first little tutorial. I want you to edit the inputs and outputs within this, and at this point I'm going to make my Grasshopper window a little larger because at times I'm going to open my Python editor over here. So behind us, we're dependent on Rhino window and what we put into it. But for these first introductories to Python, you're going to want to just work within the editor. Now, there's other things you can actually learn, and I'm sure some of you use the Python script editor directly in Rhino. But we're going to try and use it in Grasshopper because I like to jump in and out of it, like I said, from the inputs to the outputs. Now, the Python node works that way. You put in inputs, it processes, and out comes outputs. The output here is what you would send to a print line, and I'll talk about that in the future, but let's not get ahead of ourselves. Editing the inputs is as simple as right-clicking and changing the name of it. Once you change the name of it, it would change in it, and you can also add inputs and change these names. So let's do delta. I can subtract them, I can add them, I can add another one, I can subtract it, and I can do the same to the outputs. I don't know if I like Bearcat as an output. I was just playing around. So let's put it back to A. And usually you have it set to output and A, and then you'll send things in the script to A if you want to bring it out into a panel. Hopefully you have some knowledge of Grasshopper, but since nothing's running right here, there's going to be nothing in my output because there's nothing in my input, and there's nothing in my script, and there should be nothing in A currently. Let's go on to the next step. Open the Python script editor, test script, or click OK. And I'll show you exactly what I mean by this. Double click, and your Python editor opens up. You've got all this wonderful data written into comments, which I'll tell you about later. And I'm importing Rhino script syntax as RS. You can change this and have a template that doesn't do this. But basically, we are going to start with import Rhino script syntax as RS. What did it ask me to do? It said, test it, and your script should go gray. It's working, but it's not really actually doing anything. So we can click there, and what I want you to notice is when you test it, it stays open. When you hit OK, it runs it and closes it. Be sure to close your scripts as you move on to the next ones. You may have several different Python nodes in a singular canvas in Grasshopper. Change the data access types and change the type hints. So when I went in here and changed the names of these, down here I had list item, item access, list access, and tree access. Now, if you recall typing in something like a number slider and bringing it in and looking at your fancy wires, that comes in as a single line, and that would actually be an item access. Something different from the sets menu, let's say series, would bring in 0 through 9, and it comes in as a list, which means I need to set my list to a list. And you can go so far as to take these and graph them and make them a tree, and you'd have to send them into tree access. But since we're not going to graph it, I'm going to leave it as list. The other thing I said to do was look at the type hints. If this is an integer value, I would want to go into alpha, type hint, and hit integer. If I had set this on edit to rational numbers 3 decimal places, I would definitely have to go in and hit type hint and send it to float. The list is coming in as integers, so I would do type hint and move my Boolean down to integers. And that's all that est. write some life-affirming text in the Python script editor by using triple quotes. Let's open the editor. And what did I just do? I'll close that. No, I hadn't opened my other script. At least I don't think I did. No, sorry to jump around. It's just in my nature to jump around. I'm a bit squirrely. So what we have here is just like the triple quotes that made this a comment and turned it green, means it won't run as script. I did the same here, but if I take them off, another way to write multi-line comments is to simply shift hashtag in the comment. But the only problem with this is it's hard to read that. Pound, this is pound, the happiest pound day of pound my life. It's better to use those triples. Let's close it. Zoom in and delete the inputs. And sorry about that little thing there. Zoom in and delete the inputs and play with some Python operators and send them to output. So now we're actually taking out something. Please keep in mind that numbers drive, or data drives, domains, ranges, mathematics, operators, points, attributes, lines, surfaces, solids. So basically I went in here and I deleted everything here, so it tagged it off. If I added something and deleted it, you see I can get a tag. There's nothing in the script that isn't hard-coded in. So let's take a look what's in the script. And what I went in and did in a very kind of boring mathematical way, not that I'm saying math is boring, I think it's one of the most exciting things in the entire universe. But you can see I had fun with some of these operators. I used the add symbol, the minus symbol, the multiplication symbol, the divide, the exponent, double stars, the modulus, which will divide and leave the remainder, and then divide will give me this number divided by a number and then reduced to its lowest integer. It ends up being a float because of order operations, and don't even try and understand where the invisible parentheses are in this. But there's a system of orders of operations, and I was just starting to play with some of them. You don't have to do anything fancy like this. You could just start with something simple, like 3 divided by 6, reduced to its lowest, which is going to be 0, because 3 divided by 6 is a decimal, between 0 and 1, and it will actually round down to 0. Not very exciting. But if we switch that to something like 13, and we divide 13 by 6, we're going to get 2, because 13 divided by 6 is just above 2, and it's going to round down to 2. Enough said. Still kind of dull. Increment and decrement, I removed my inputs. Let's open the script and see how I wrote this. And I wrote a little shortcut that they use in Python a lot because we're tired. It seems tiring to write it all out. You don't need these comments at the top. Sometimes I leave them because they just default coming up. But we're dealing with our first variables. A is equal to 10. I set it hard code to 10, and I set B to 10. And then I wrote a little script here that means A plus equals 2 means A equals A plus 2. B minus equals 2 is B is equal to B minus 2. So if I hard code change this to 102 and hit test, that's going to raise A to 104. And if I take this one up to 1034 and test it, it's going to bring that down to 1032. Pretty simple stuff. This is where it gets interesting. Watch my script as I play with it. It's actually outputting strings. So if this is lower, it's telling me they're not equal. It's telling me they're equal. It's saying they're not less than. And in the end, it says x and y both have values greater than 0. It's set 1 to 0. And it says either x or y is not equal to 0. I'm not telling you if it's x or y. I'm not that smart of a coder. And if both are 0, x and y do not have values greater than 0. Let's take a look at the script in here. The first initial one's pretty simple. Using a conditional. Think of conditionals as going about your life. If I had breakfast, if I had to use the washroom, if I was late for work, what are the consequences? And equals is not what it was in the operators. Setting something equal to something is not assigning a value to it. If I put x equals y, this simply would be y, x is, and then becomes y. But what we're saying is if x is equal to y, if our inputs are equal, it will print equal. But since our inputs are not equal, it goes to the else statement and types not equal. Let's close that one out. Let's open this one. It has the same result, but how did I write it? If x exclamation mark equal sign, which means not equal to y, print not equal. Well, this happens they're not equal, so it prints equal. if they were not, if y was not equal to, this is interesting, if x was not equal to y, which it is equal to y, it would skip over the source and go to else and produce equal. So I'm asking if x is not equal to y is true, and it's not, then you would have to go to the else statement. Hopefully that logic and conditional makes a little sense to you. The next one's a little more interesting. I simply said if x is less than y, print less than, and if it's not less than, if that doesn't prove true, it will simply print the else statement, not less than. Keep in mind the computer does not read what's in these strings and understand what's in them. It simply outputs them. You have to write your script so it understands these keywords and does what you say, kind of like a dog when you're speaking to it and it can listen to certain keywords. Let's shut that and let's do the last one, where I used an elif statement, which is like a else if, which allows me to play a little more detailed in this script. And that's where I get to the point that if x is greater than 0 and y is greater than 0, print x and y both have values greater than 0. Elif x is greater than 0 or y is greater than 0, either x or y is equal to 0. Of course, it's not saying which one. And then if either one of those fail, it comes out x and y do not have values greater than 0. So set them both to 0. This one is not true, this is not true, this is true, and that's why x and y do not have values greater than 0. We're almost done. We're getting in the loops. Loops are kind of fun. I have 4 here, and I'm basically taking an index, or I'm doing something. Let's open the script and see what's going on. It's a wonderful for I, or something, in a range. And the range is set to x, which means that's the end, the stop. You can, and I'll show you in the next script, write the start, the stop, and the step. And then I'm printing I. So I is going through a range of x. X goes from 0 to 4, so it prints as indices 0, 1, 2, 3, which is actually 0, 1, 2, 3. Keep in mind we start counting at 0. So if you go into a bar with 3 friends and you want 3 beers, you ask for 3 beers. We'll also go into here and we'll take a look at the range where I've actually put in the words start, stop, step, and changed x to those as inputs. I obviously went in here and changed type int to integers. I left them as single list items. I have a start of 3, a end of 29, and I'm jumping up by 4. 3, 7, 11, 15, 19, 23, 27. If I stepped up by 7, I would get 3, 10, 17, 24. A fun little exercise and a fun little script to start making sense of what is going on here. And if I start to count at 1 or 0, it's still going to step up by 7 at 1 and go all the way up to the highest. The output down here is what we're starting to see, and that's the output that will come to the output here. Nice way to test, and you don't have to go into the editor mode and tools and debug. But that's what we end with. Let's keep rolling right along. This is where we're going to learn a little bit about lists and a little more about Python. And it gets a little confusing here. List functions, what are they and what are available to you? When I write a list in a panel like this, and I make it multi-line data off, or on, it's going to take whatever data I put in and it really doesn't think what it is. So sin x is just stuff, taco is taco, 789 is just 789, 9 is just 9. But it comes in as a list, and I've had to set my list access to list. I have an integer here that's picking an index. So if I pick index 0, it's going to give me 1. I ran it through a negative node here, so if I set in 9 and I'm getting negative 9, it's going to count back 9 from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and ends up with 45 and shows me index 6. So it's interesting to count from the front and the back. Keep in mind that index negative 1 is actually the last item. So we start counting at 0, but we don't start counting backwards from 0. That wouldn't make any sense. We start counting backwards from negative 1, negative 2, negative 3, negative 4. So I've just found a way to bring that node in here. So that's an interesting thing. Let's take the data and just keep in mind what the data is. And now what I'm doing in this script is having fun with, let's take a look. I'll try and keep it big so you can see what's going on. I've produced the list X, and I've set what is in X to a list. Now I can analyze the list. I can type the function length len list, and there's 15 items in that list. If I say print list -1, it's going to print the last item in that list, which just happens to be -1 in my list. I'm sorry, before I did that, I appended another function append. 77, put 77 at the end of that list. And it's hard for you to see that, but that's what the list is actually looking like. So if I look at the last digit now, 77 is the item. Now I append it with another 77, but even though it was reading 77 here as numbers, it's now reading these as a string because I put them in quote. So you've got 77 at the end, but you now have 77 again as a string. So if I printed that again, you would see 77 the same. But keep in mind, this 77 is not that 77. I hope that makes sense. Otherwise, get an intro to Python and play with list functions. The print type list -1 is going to tell me it's a string that time, not an integer. And that's why I tested it. Just showing a few examples. This one I'm bringing in a series, but I stepped this series so the numbers are a little different. I stepped it up by 2. So this one will go 0 to 9. This one will go 0, 2, 4, 6, 8, 10, 12, up to 18. And now I've got a bunch of funny, funky stuff going and being printed on each of these lines. And if I can keep them to a single line, that might make a little more friendly sense to everybody. And this is a little dry, but things are going to get real exciting real quick with Grasshopper and with Python. So I'm running out the whole item here, and we're looking at the script. Keep in mind with the numbers that were coming in. But if list X is the top list, and I actually put both series into that list and didn't use Y, I can actually get rid of this and it's not going to affect my code in any way, shape, or form. At least I don't think it is. I don't think I had any Y in there. So let's take list X, which is actually holding down shift and bringing both lists in, and then reverse that list and print it. So we get everything from 18 all the way back to 0, and then 9 back to 0 again. Then I'm typing in print the max, another function of a list, and min. 18 is the highest, 0 is the lowest. Then I'm going down and I'm sorting the list again, even though I had it in reverse and printing lists. So it takes all the digits and puts the zeros together, the 1s, the 2s together, the 4s together, the 6s together, all the way up to 18. Then I'm inserting at 3 the word string as a string. And I thought that would be interesting. So you count 0, 1, 2, 3, which is now string, and print the list. I append the list with hot taco, which throws at the end of it, hot taco. If I've extended that out, you'll see hot taco is the last item in the list. Print the list again. I delete list item 3, which happens to be string, and print the list again, and string is gone. And I pop item 8, but I want to list and print pop item 8, which happens to be 5, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, and it tells me you just popped 5. And then I print the list again, and you'll see one of the 5 is the only 5 is missing. The last thing I did was I made a new list from list, start, stop, step, and printed that list. So I started the second 0, 1, 2. I'm going to step up by 3, 1, 2, 3, and then I'm going to step up by 3, 1, 2, 3. Which is 6, then I'm going to step up 1, 2, 3, which is 8, and then 1, 2, 3, which is 10. And I printed a new list from that list. So those are some list functions you can play with. Pretty infinite in what you can do. Play around and see how it goes. We're going to get almost done this. We're at 24 minutes. Half an hour sounds pretty good for a longer video for me, about double what I've done. I have 2 series here. They both have a count of 3. I'm stepping this one up 5. The numbers coming out of this list are basically a 0, 1, 2. And I did something fun here. I grafted this data and actually made it on its own branches. I didn't have to do that, but I wanted to show you this cool function that I wasn't making sense of on an earlier video this week. And I came across list extend. So I have a X and Y, which I set into variables X list and Y list. And then I'm taking X list and extending it with Y list. And because this is coming in as grafted data, as a tree data, it's going to take list X and throw on those in the end. So this is kind of an interesting function when you go through and see how this actually works. So I'll leave it for you to play and have fun with how you can take double digits and start to treat them as single digits. And that's kind of what research leads to, a little bit of development as I start to think, what if I was to use the extend list function with geometries that could split double digits, or let's say even triple digits, or as many digits as you want, into these type of list items. And I think that's a very cool counter that I never thought to be maybe the radius or maybe the distance of things between geometries. Keep in mind, Python, the control of Python in the Grasshopper is going to enable you even more than what you could do in Grasshopper for Rhino. Now we get into functions. They're two last things I want to talk about, and they're very exciting because functions to wrap your head around, and we'll end with errors and debugging. And I think we're done this first tutorial. I'm going to click on here and take a look at the script. And what I've done, and I still have it in Rhino script syntax, but you'll see I wrote it down here and commented it out, Rhino geometry. Unless you have a specific function that you have to type rs dot and get it all the functions, if I actually went down here and typed rs dot, it's going to show me everything that's in there. If I chose something simple like well, I don't even know where I would go with that. And actually, I won't spend much time on RS. If I actually commented this out and activated my Rhino geometry, I'll show you here RG. If I went into arc dot, I get in even farther. So angle. And then when I bring up my parentheses, it will start to show me what is in the Rhino developer site as to what is needed and what it's asking for. And this is where things get a little trickier and you've got to go into the Rhino developer page. I'm going to leave that off and I'm going to focus mostly on that. And I think what I'll do is just comment this out with a triple quote and triple quote at the end so it understands what it's commenting out. And take a look at this little piece of information here. And I put in a little print function here, at least I thought I did. Print, I thought I printed in, maybe not on, oh, we're looking at the top one. Sorry, I always confuse myself when I look up and down. I was looking at these results, looking at this script, and that's one reason why you want to close these. But basically, Rhino script syntax as RS allows me, it's not even needed because I didn't use RS, a definition as a function. I call it whatever I want, rectangle, area. I give it a length and a width as parameter. You can call that dog and cat as you want. We'll call area what length times width is, and we have to return the area. And the return will send it back out, and now I can print, not call the function, but I can print rec area xy, and as I change xy, I change my little calculator. So it's a nice little calculator script using a function. You could run it in Rhino script syntax, you could write it in Rhino geometry. It's not going to matter. Now this is the last one I want to end with because I find it very exciting. And I'll open this script up and I'll show you exactly how functions need to start working. And even though we've been dealing with everything in a straight order, top to bottom, and Grasshopper always goes left to right, I'm going to bring in Rhino script syntax as RS. I'm actually going to write this function a little bit out of order and talk about it out of order. What I have here, and I'll make this as big as I can. It's exciting to look at because my head, when you wrap your head around new ideas, it becomes very exciting. This is a loop function that runs twice. The first time it runs in, I'm not sure why I haven't taken this off. I'll go and put in Rhino.geometry as RG because we're not actually using that, and that function will run just as well. And we haven't outputted anything except the output to the A. We don't really need that output, but we can show what it would be in the print function. Now, the way a definition works is, let's possibly comment out this one, just so we get in the habit of thinking we actually are going to be working in Rhino.geometry or Rhino common. And this may be a little confusing to end this tutorial with, but I'm just going to do it. Let's scroll up to here and see what this script does. It is saying, make a definition of a function, call that function something, give it some parameters, and then run it through something like a range and print the number of that. Now that needs to be called as a function, and you will call that function as main, which means I can put in the initial variables local in this calling of the main function because I've actually called this function later within this. So I tuck this detailed function into the body of this function locally of main, and then I run main. So let's see what happens. And this is a great practice that I experienced when I was looking at the site from Michigan. Let's call the function loop function. It needs to have a num and a t, which will be my start and iteration, which are actually parametric, coming in as single items, both as integers. Hope that makes sense. When I call the function, because I'm dealing with the main function here, I'm going to use num and I'm going to use t. And as long as I take those variables, you don't have to call them the same name, but the technique of capitalizing them allows you to recognize you've taken these and called this function, loop function. So I takes what I was, I will run through starting at 1 and go to t, so 1 to 5, and it will multiply 2, which is the num, the start, by itself times the iteration number, being 0, 1, 2, 3, 4. It won't be 0 because I started the count at 1. There'll be no multiplication by 0. So play with this and watch your numbers change. Because I have two scripts running, actually I should test it. I shouldn't have two scripts running, otherwise you were seeing that space. Try and make sense what's happening here. The number starts, I've started at 4, I've multiplied it by 4 times 1 in the first iteration. Now it's set to 4. Now I'm going to set to 4. Now 4 goes in, and 4 gets multiplied by 4 times 2, which becomes 8. 8 goes in as num, gets multiplied by 2, is 8 plus 16. 8 times 3, which is 24. And then when we have that number coming out, we're going to end up multiplying that in its fourth iteration, because we're allowing it to go up to 5, 0, 1, 2, 3, 4. It will end up being the multiple of 96. So sorry to stumble over my own words in there, but that's a very good way of ending with functions, learning a bit about Python and playing with a very simple script that I'll have up on GitHub for you to experience and get at the first chapter so we can start going a lot deeper into these geometries and end up producing some beautiful forms and convert everything from Rhino script syntax over to Rhino geometry, and I will be importing maths and doing some very fun exercises within it. So a very dry video for 36 minutes, my first longer one. It's going to have a very kind of educated pace at that. I'm running these at the Kansas City Art Institute in my classes, so the students can watch these afterwards. And some of these people have never even opened a Python editor or opened any of these nodes or worked in functions, let alone worked in Grasshopper. They've been used to doing CAD design in Rhino or in Tinkercad or Blender or SketchUp or something like that. Very excited to see where this goes. I'll just pop up my other image for a second and suggest to anybody who is interested in getting into development, you definitely want to have this available. There's some beautiful scripts to play with on atlv.org. Michigan, if I plugged into here, I have to put a plug in recommending this course. Sign in here. And basically taking design computing, 3D modeling in Rhinoceros with Python Rhino script. Now you're actually writing within the Rhino script editor, not actually Grasshopper, but you can convert that over very easily from Rhino script syntax into the nodes in Grasshopper, GhPython. And then there's a whole series of other things I find interesting. I invite you all to jump in and friend and go on and become a member. And in the time I've been here, I think we've actually pulled in a couple more. I'll keep thanking people as they come, 5 new members, and we'll see where this ends up leading. And for those that actually follow Grasshopper 3D. I have started 2 groups as of last night, so I don't have many members, but I have one for Rhino script, Rhino Common specifically, and one for GhPython scripts. So wherever you want to interface and talk, and if you actually want to have some one-on-one, I'll do a little plug of Patreon, Patreon home. Nope, and I missed it. Oh, what did I do? Patreon. That's a totally other site. Patreon. Maybe I'll edit this out, or maybe I'll just show you how my life kind of goes. But Patreon, I've just started that site, and I'll be very specific to how I kind of spend my time with individuals. If they want to have one-on-one half an hour a month, or maybe even a week for that matter. Simple videos that are on there. I put all my past ones, and as we start to make these more and more private and specific to people that really want to go far into these scripts, please take a look at the ones I put up for free all over GitHub. All the files are on GitHub at M. Wickerson and YouTube. And I'm rambling on at the end of the video. I guess I just don't know how to say goodbye. But there's plenty of opportunity for people to jump on board and become part of GhPython script. Thanks very much for watching.